Welcome, dear. Program Evaluation Review Technique, PERT. Program or Project Evaluation and Review Technique, PERT, is a project management tool used to schedule, organize, and coordinate tasks within a project. It is basically a method to analyze the tasks involved in completing a given project, especially the time needed to complete each task, and to identify the minimum time needed to complete the total project. PERT planning involves the following steps. PERT planning involves the following steps. Number 1. Identify the specific activities and milestones. Number 2. Determine the proper sequence of the activities. Number 3. Construct a network diagram. Number 4. Estimate the time required for each activity. Number 5. Determine the critical path. Number 6. Update the PERT chart as the project progresses. The main objective of PERT is to facilitate decision-making and to reduce both the time and cost required to complete a project. Again, the main objective of PERT is to facilitate decision-making and to reduce both the time and costs required to complete a project. PERT planning involves the following steps that are described below. Number 1. Identify the specific activities and milestones, which the activities are the tasks required to complete a project. The milestones are the events marking the beginning and the end of one or more activities. It is helpful to list the tasks in a table that in later steps can be expanded to include information on sequence and duration. Next, number 2. Determine the proper sequence of the activities. Yes, this step may be combined with the activity identification step, since the activity sequence is evident for some tasks. Other tasks may require more analysis to determine the exact order in which they must be performed. Number 3. Construct a network diagram using the activity sequence information. A network diagram can be drawn showing the sequence of the serial and parallel activities. Each activity represents a node in the network, and the arrows represents the relation between activities. Software packages simplify this step by automatically converting tabular activity information into a network diagram. Estimate the time required for each activity. Number 4. Estimate the time required for each activity. Weeks are a commonly used unit of time for activity completion, but any consistent unit of time can be used. Months. Okay. A distinguishing feature of PERT is its ability to deal with uncertainty in activity completion time. For each activity, the model usually includes 3 time estimates. Optimistic time, that generally the shortest time in which the activity can be completed. Most likely time, the completion time having the highest probability. Note that this time is different from the expected time. The next time, pessimistic time is the longest time that an activity might require. The expected time for each activity can be approximated using the following weighted average. Expected time equal optimistic plus 4 dot most likely plus pessimistic divided 6. This expected time may be displayed on the network diagram. To calculate the variance for each activity completion time, if 3 standard deviation times were selected for the optimistic and pessimistic times, then there are 6 standard deviations between them. So the variance is given by pessimistic minus optimistic divided 6 square. Number 5. Determine the critical path. The critical path is determined by adding the times for the activities in each sequence and determining the longest path in the project. If the critical path is not immediately obvious, it may be helpful to determine the following 4 quantities for each activity. ES, earliest start time. EF, earliest finish time. LS, latest start time. LF, latest finish time. Example as a case study. In the following example, the project manager knows the succession of the project activities and the optimistic, pessimistic, and most likely time in weeks for the following activities. Activity A. Optimistic time is 9. Pessimistic time 15. Most likely time 12. Activity B. 5, 13, 9. Activity C. 8, 12, 10. Activity D. 7, 17, 9. Activity E. 18, 34, 23. Activity F. 9, 15, 9. G. 30, 40, 35. H. 35, 49, 39. I. 12, 18, 15. J. 9, 3, 4. K. 11, 9, 9. Please define the optimistic time, pessimistic time, and most likely time. Number 2, calculate the expected time for each activity. Number 3, calculate the variance for each activity. Good luck.